Hey guys, welcome back to another video. In today's video guys, we are going to be having a look at file sizes. Now this type of questions rarely come in your papers. Actually, it's almost once a year, but when they do come, many students fail to not get the right answer. It's such a simple concept, but oftentimes students just get confused and mislead. These questions mislead them and then they get the wrong answer. Therefore, I decided to do like 10 questions that will cover the entire thing that you need to know about file sizes. Okay, so let's start off with just questions. I'll explain what file sizes is as we go over all the different types of questions. So let's begin with this. Okay, so an image is stored on a computer and the image is 16-bit and it is 100 pixels high and 150 pixels wide. So the key information you need to know is the values. Oops, let's just reduce that. Is the values. Okay, so we need to look at the values here. Okay, nothing about the theory, the values. So first of all, we're being told that this is 16-bit. We're told that it is 100 pixels by 150 pixels. Now what this simply means, this is the screen or image resolution in this case. This is the image resolution. Okay, this is the image resolution. Now we are supposed to calculate the file size of the image in bytes. We have to look at the file size in bytes. Now, how do you do this type of question? First of all, let's find the image resolution. Okay, so we're going to start off, find the image resolution. To find the image resolution, just do 100 times 150. I'm not going to just rewrite it. I'm just going to erase this and write it here. 100 times 150. 100 times 150 is 15 with 3 zeros, so 15,000. Now what we just found was 15,000 pixels. Okay, that is how you look at screen resolution. 15,000 pixels. But remember, we need to make this pixels into bytes. How do you do that? That's an easy step process. To convert a pixel into bits, we multiply everything by 8. To make bits into bytes, we divide by 8. So that most likely means is that if I multiply these pixels, I will get, now look, it's a 16-bit, so here it won't be 8 actually, it will be 16. If it was an 8-bit, then we will do what I just told you. But if it's a 16-bit, I will do type 16 and then divide by 16. Okay, times 16, divide by 16. Okay, sorry, divide by 8. Oops, I really messing this up. Divide by 8, because whenever you want to convert bits into bytes, you have to divide by 8. Okay, now this value which I'm just gonna highlight right now, this value will depend on the question. Right now it is a 16-bit, that's for it's 16. If it was 8-bit, you will multiply by 8. So now I'm going to take these pixels, 15,000, and I'm going to multiply it with 16. If I multiply this by 16, 15 times 16 is 240. I'm just going to save time by telling you that. And then you add 3 zeros. That will make it 250,000 bits. But we want the answer in bytes, so we will divide everything by 8. That shall give us 30,000 bytes. I'm hoping you understood that. Now, let's go to the next question. Again, let me teach you something. We have bits, we have bytes, we have kilobytes, and then we have megabytes. What is the conversion rate? From bits to bytes, we multiply by 8. Okay, sorry, we divide by 8. Whoa, I'm getting confused myself, huh? We divide by 8. Okay, from bytes to kilobytes, we divide by 1024. From kilobytes to megabytes, we divide by 1024. Okay, always make it like a series, a chain. Okay, so let's see how we can do this type of question. Let's just keep this in mind. Keep this information in your mind. Okay, just keep that in your mind. Let's look at this question now. Georgia is a wedding photographer and she wants to store 10 photographs. She wants to store how many photographs? 10 photographs. So I think in the end we'll have to multiply by 10 because we will calculate for the image resolution for one and then multiply by 10. Each photograph, look at this, each photograph is 100 pixels wide, 50 pixels high. Okay, so this right here is the image resolution. Okay, now the next thing we are told, this image is 8-bit. This time it's 8-bit. Last time it was 16-bit. So this time we'll multiply 8 times 8. It's telling us to calculate the total file size in kilobytes. So another keyword to know, we have to know in kilobytes. Last time it was bytes. Now it's kilobytes. Of all the photographs. For this calculation, you may use 1024 or 1000. So you know what I was telling you, divide by 1024. You can also divide it by 1000 because it's just easier to use. So let's see. First of all, let's try to calculate the image resolution. Always start off with image resolution. They always give you the pixels. So 100 pixels times 50 pixels gives us 5000 pixels. That is the image resolution. So this right here, if I highlight in blue, this right here is my image resolution. Okay. The next thing we're told that these photographs are 8-bit. So let's multiply this 5000 times 8. Will give us, I think, 40,000. This 40,000 is bits. Now, I told you previously to convert from bits to bytes, we shall divide by 8. From bytes to kilobytes, we divide by 1000 or 1024. So let's do that. Let's convert it to bytes first of all. To convert it to bytes, we will do 40,000 divided by 8. That will give us back to 5,000, isn't it? That will give us 5,000 bytes. Okay, that is giving us 5,000 bytes. Now we have bytes. We need to convert this to kilobytes. And what did I say? To convert this to kilobytes, we divide by 1,000. We divide by 1,000. So we're going to say 5,000 bytes divide by 1,000 will give us 50 kilobytes. Now, here's where many students will lose marks. We're not done yet. It's for 10 photographs. This was only for one photograph. This was only for one photograph. Okay, so now we have to do, of course, 50 times 10 to give us 50 KB. So the answer 50 KB. If you used 1024 here, you will get 48 or 49 KB. But because we're not allowed calculators, I'll use 1000. So 50 is the right answer. I'm hoping you understood this, right? I'm hoping you understood both of these questions. Let's move on to the next question. Next question, it's a similar question, only 2 marks. Okay, so let's see how this type of question is framed. It says L has a file stored on her computer that is 20 MB, and then Jordan has a file that's 10 GB. We already know the larger file is 10 GB, but why is it the larger file? Now, we know that the order always goes from bits to bytes to kilobytes to megabytes to gigabytes and then terabytes. Okay, it always goes like this: bits, bytes, kilobytes, megabytes, so on and so forth. So without even needing to understand this concept, if you use a phone, you will already know that gigabytes is bigger, right? You will already know gigabytes is bigger than 20 MB. Okay, so 10 gigabytes is bigger than 20 MB. Okay, there's not a lot of explanation needed here. This is kind of general knowledge. Let's look at the other one. Now here, maybe a bit confusing. Okay, so let's see. We have 3500 KB, we have 3 MB. Okay, which is bigger? Now, let's see. The way you do this is you try to convert it. Now, MB is bigger than KB. Now, if I want to go from KB to MB, if I want to make this right here to MB, so that I can compare, what will I do? I will divide it by 1000. I will divide it by 1000. So 3500 divided by 1000 will actually be 3.5 MB. So this is actually 3.5 MB. Which is bigger? 3 MB or 3.5 MB? 3.5 MB. That's what? That is right. Okay, so simple. You just convert it from KB to MB. Remember, if you want to do MB to GB, I will divide by 1000 again. Okay, so it's simple like that. Move on to the next question. The next question looks like it's talking about someone who is called Marley. Okay, so we have someone called Marley, and she wants to store 10 8-bit color images. 10 again, look at that, 10 again. Please pay attention to the numbers of images. Each image, okay, 500 pixels wide, 300 pixels high. So this again, I want to label it like usual. This is the image resolution. Okay, so let's start off with calculating image resolution. Image resolution. The image resolution for this case will be 500 times 300, which will be 15, and then 4 zeros. 1, 2, 3, 4. That's 150,000 pixels. Okay, 150,000 pixels. Now, that is our image resolution. We want an 8-bit. So, 150,000 pixels. We need to multiply it by 8. Okay, we multiply that by 8. What is that? It's going to be a big value, but let's do it. 120. So 120 and then 4 zeros. Oops, that doesn't even make sense. 4 zeros, I think it's 1.2 million. So this is 1.2 million bits. But we want what? We want megabytes. We want megabytes. MB. We want megabytes. So let's try to do this. So if we want megabytes, right now we have bits. We need to convert this bits into bytes. So this will give us back 250,000 bytes. So it's almost like a reverse. So some people choose to ignore this step, but I'm going to do it so that you understand it. Okay? Now, we need to do this 150,000 bytes. We got to divide it by 1000. So we'll remove 3 zeros. It will give us 150 kilobytes. We have to now do 150 again, divide by 1000. How much will this be? Let's see. 0.15. So we'll give us 0.15 MB. Now finally, this 0.15 MB times 10 will give us, so just do it here, shall give us, because it's 10 photographs, okay, 10 photos, so this will give us 1.5 MB, and that should be the answer. I'm hoping you followed. So the trick here is just this thing I'm going to tell you here. Look, you start off, let me tell you this trick here. You start off with bits. These bits go to bytes. These bytes go to kilobytes. Then megabytes, gigabytes, so on. So from bits to bytes, divide by 8. This divide by 1000. This divide by 1000. This divide by 1000. That's the trick. So if they want me to do megabytes, I'll start off from here and work my way down. Then the number of photographs will be the answer. Okay? So I'm hoping you have understood that. Let's go to the next question. Next question looks like a bit different. Let's see. Why is it different? Why does it look different? But let's see. Let's get the highlighter out. A 32-second clip. So we have a 32-second. This time it's not in bits or bytes. This time it's in seconds. This sound will be sampled 16,000 times. And each sample will be stored using 8 bits. Now, something you need to call, it's called sample resolution. Okay? Is the number of samples it takes per second. Number of samples it takes per second. So, number of samples per second. Okay? So here, in this case, it is taking 62 thousandths per second. So if we have 32 seconds, 16,000 times 32 will give us the amount of samples per second. Okay? Will give us the amount of samples per second. And here it will be 512,000. I'm just going to save you time. 512,000. Okay? 512,000. This will be right here in pixels. Sorry, this will be in bits. My bad. Or what? Yeah. No, sorry. This will be in pixels. Yeah. This will be in pixels. Yeah. This because it is the resolution. Still in resolution. Now this will multiply it by 8. So 512,000 multiplied by 8 will give us something, because the next step we know we're going to do 512,000 divide by 8. So if we're dividing, we don't have to do this step. It will cancel out each other. Okay? So we just have to do 512,000 divide by 1,000, because we want kilobytes. So we'll cancel these 3 zeros, cancel these 3 zeros, you will get 512 KB. Okay, you'll get 512 KB. So that is the answer. Let's move on to the next question. Okay, different units can be used to represent the size of a file as it changes. Fill in the missing units. Okay, we've done this. Bit. Now, what's a nibble? Now, you see, a bit is, for example, an 8-bit is something like this. See, there are 8 values. There are 8 values. What is a nibble? A nibble is just 4 values. Okay, if this was eliminated, this is called a nibble. Nibble is just 4 values. So, okay, that's what a nibble is. So nibble and a bit is just 1 value, 1 standalone value. Nibble, 4 values. A byte, 8 values. So for next, after bit, it's going to be nibble. After the nibble, it's going to be a byte. After the kilobyte, it's going to be the megabyte. Okay, and the gigabyte. It's such an easy question. Very, very easy question. Okay, we move on to the next question. Okay, so you can see now it's just repetitive. Look at it, it's so repetitive now. 16-bit, 200 pixels, 256 pixels. Let's look at the resolution first. Resolution, 256 times 200. What is that? I'll have to do some mathematics here. 512? Yeah. So 512 like that with 2 zeros. Which makes it 51,200. So 51,200 pixels. It is 16 bits. So 51,200 times 16 to give us the number of bits. They want us to find KB. So 51,200. Let's multiply this together. What do you get? 512 times 16. 512 times 16. I'm going to save time by just using a calculator, but in the exam, you're going to have to do it the normal way. But this is going to give us 8192 with 2 zeros. So this much. So 819,200 bits. Now we divide this by 8. So 819,200 divided by 8. This will take a lot of time in the exam, but I think you just gotta do it. You just have to do it. There's no other shortcut to doing long division or anything like that. So yeah, you just have to do it the long way. 819,200 divide by 8, because we want the number of bytes, so it's going to give us 102,400 bytes. We want kilobytes, so we're going to do 102,400 divided by 1,000, cancels 2 zeros. 102.4 will be the answer. So the answer is 102.4 kilobytes, because 102 divided by 10 is just taking it like that. Sorry, yeah. Okay, so this will become like this. There'll be a point here. So I'm hoping you have understood this question. Okay, let's move on to the next question. Another simple question looks like. It says Steffi has a number of files of different sizes that contains her work. Tick to show whether each is true. Let's see. Okay, let's highlight this. 47 KB is larger than 10 AB. Let's just confirm by just doing it. KB to MB. I gotta divide by 1000. So 47 divided by 1000 is actually 1, 2, 3. It's actually 0.047 MB. Which is bigger? This is false, because this is smaller, not larger. Let's go to the next one. 250 bytes is smaller than 0.5 MB. Let's just see. 250 bytes. I'm going to divide it by 1000 to get kilobytes. 1, 2. So that is 0.25 kilobytes. To get megabytes, divide this again by 1000. So it is smaller. So that is true. You can tell it's such a small value. That is true. Let's look at 50 GB is larger than 100 GB. I already know it's true. Already true. We're not going to have to calculate this. 1 TB is smaller than 4 GB. That is false. 1 TB is 1000 gigabytes, which is not that. Okay, so pretty simple. Some of the questions, some of them you don't even have to do the entire calculations and stuff. So you just get straight the answer. Go to the final question. Looks like a similar question like what we have been doing, but this time they've given us the pixels. We don't even have to calculate it, so you can see how simple this is. So 1000 pixels, let's get the bits by multiplying by 16. That will be 16,000. And to get bytes, we do 16,000 divided by 8, so that will be 2,000 bytes. So 2,000 bytes. So that marks the end of this video. I'm hoping you've understood all the concepts that I talked about today. I'll leave this document down in the description along with my solution, which will also be down in the description. So I'll continue to make these types of topic based videos because the exams are coming close and many people struggle with these types of questions. I'll start doing paper 2, paper 1, different subjects too. So hit the notification bell, subscribe, and thank you guys for watching this video. I'll see you in the next video.